Good day, everyone. I am Faisa, I'm Metopher, and now I will be discuss the continuation of the carbohydrates. Some important oligosaccharides. Oligomers of sugar frequently occurs as disaccharides formed by linking two monosaccharides units by glycosidic bonds. Three of the most important examples of oligosaccharides are disaccharides. They are sucrose, lactose, and maltose. Two other disaccharides, isomaltose and cellulose, are shown for comparison. In short, oligosaccharides are short chains of sugar made by joining a few monosaccharides through glycosidic bond. The simplest and most compound one are the saccharides, which contain two sugar units. The important is the sucrose, table sugar, glucose plus fructose. Lactose is a milk sugar, lactose plus glucose. Maltose naman, it is a malt sugar, glucose plus glucose. So other related disaccharides like isomaltose and cellulose help show how the type of bond affect each sugar structures and properties. What makes sucrose an important compound? Sucrose or table sugar comes from sugarcane and sugar beets. It is made up of two monosaccharides, A. glucose and B. fructose, linked by a glycosidic bond between glucoses C1 and fructoses C2. Because both anomeric carbons are involved, sucrose is not a reducing carbon. So when it is sucrose or table sugars is come from sugarcane and sugar beets. Also, um, it can join by band between glucoses. Because of that, both reactive carbons are used. Sucrose cannot act as a reducing sugar. The structures of several important disaccharides. These saccharides are made of two sugars linked by a glycosidic bond. The A alpha and B beta forms depends on the position of the OH. Above the ring is B, below is A. Sucrose, it means glucose plus fructose, has both anomeric carbons joined, so it has no free carbon, meaning it's not reducing sugar. When you say fructose naman, is sweeter and has fewer calories than sucrose. Sucralose is a modified form of sucrose that calorie-free. Aspartame and saccharin are artificial sweeteners, so they taste sweet but may have some health risks. Artificial sweeteners can affect both bacteria and blood glucose control, so they should be used in moderation. Are any one disaccharides important to us? Lactose is an important disaccharide made of B, D, galactose, and D glucose linked by A, B1 to 4. Glycosidic bond. It is a reducing sugar because glucose's anomeric carbon is free, and its metabolism affect health, especially in people with lactose intolerance. Lactose is important disaccharide found in milk. It made of two sugars, galactose and glucose, joined by B1 to 4 bond. It is a reducing sugar because one carbon in glucose is free to react. Our body breaks it down using the enzyme lactase. If someone lacks this enzyme that they can't digest lactose properly, leading to lactose intolerance. Artificial sweeteners and other disaccharides. Fructose is sweeter than sucrose. It is a table sugar and is often used in corn syrup to make foods taste sweeter. Artificial sweeteners like saccharin, aspartame, and sucralose are used as low-calorie sugar substitutes because they taste sweet but provide little or no energy. Sucralose is made by replacing some hydroxylic group in sugar with chlorine atoms, which prevent the body from breaking it down, making it non-calorie. Some research suggests that sweeteners might affect gut bacteria and influence metabolism, but more studies are needed. Lactose, milk sugar. It is a natural disaccharides made of B-D-galactose and B-D-glucose, B1 to 4. It is a reducing sugar that the enzyme lactase helps digest in a small intestine. Intolerance and lactose-free product. Lactose intolerance happens when the body doesn't make enough lactase, the enzyme that breaks down lactose, the milk sugar. Without it, lactose stays underdigested, causing gas, bloated, and diarrhea. It is more common among non-Caucasian groups. Galactosemia is a different condition caused by an enzyme defect that prevents the body from using galactose, a part of lactose. People who are lactose intolerant can drink lactose-free milk or take lactase enzyme tablets to help digest diarrhea. Maltose is another disaccharide made of two glucose molecules joined by an A1 to 4 bond. It is forming starch breaks down. Structures and function of polysaccharides. Polysaccharides are long chains made of monosaccharides. Homopolysaccharides have only one type of sugar. Heteropolysaccharides have more than one type. Glucose is the most common building blocks. It is a monomers. A linkage are used for energy storage, while B linkage provides structure. Starch and glycogen storage energy. Cellulose and chitin, it is a given structure and support. And when you see starch, starch stores glucose in plants and is made of a D-glucose units. It has two parts, amylose and amylopectin. When you see amylose is a unbranches with A1 to 4 bonds. Amylopectin is a branch with a A1 to 4 and A1 to 6 bonds. Humans digest starch using amylase, which breaks a linkage. B linkage, like in cellulose, cannot be digested by human. In short, polysaccharides are big sugar molecules. Some store energy, the starch and glycogen is other build structure like cellulose and chitin. Human can digest a type bond but not B type ones. Dietary fiber. When you say dietary fiber is made of polysaccharides that the body cannot digest. It helps move food through the intestine and lowers cholesterol. There are two types of fiber, insoluble fiber and soluble fiber. When you see insoluble fiber, it is add bulk to stool and prevent constipation. Soluble fiber is a dissolves in water and help lower cholesterol and blood sugar. Both types improve digestion and reduce the risk of heart diseases and diabetes. Cellulose insoluble fiber and pectin and amylopectin soluble fiber. Fiber is a plant's material we can digest. It keeps the digestive system healthy, help control cholesterol and sugar, and lowers disease risk. Chitin is a structural polysaccharide found in insect shells and fungi cell walls. It is made of N acetylglucosamine units that give strength and protection. And the peptidoglycan is form bacterial cell walls. It is made of NAG and NAM units linked by peptides give the wall rigidity and strength, while the cellulose is a B124 linked locus polymers found in plant cells walls. It provides structures and support, but human cannot digest it. Pectin is a polysaccharide made of galacturonic acid found in a plant cell's walls. It is used in gelling agents and jams and jellies. Lignin is a complex polymer in woody plants that make them hard and durable, while the glycosaminoglycans are repeating disaccharides found and connective tissues. They help provide support, flexibility, and lubrication, like and joint. Glycoproteins are protein with attached sugars. They play role in cell recognition, communication, and immunity, while the proteoglycans are glycoproteins with many carbohydrate chains found in connective tissues. They help maintain structure and cushioning, but their build-up can cause disorders like Hurler syndrome. In simple terms, pectin help plants and jams stick together, lignin make wood strong, and while the GAGs and proteoglycans support tissues, and glycoproteins help cells communicate and defend the body. I hope you learned the lesson and understand. Thank you.